What's up, guys? It's Taylor. Welcome back to The Blueprint, a channel in which we talk about software engineering principles, and sometimes I build stuff. But not today. Today is actually another episode of Good, Better, Best, our ongoing whiteboarding series here on this channel. So just like last time, I'm going to put the timestamps in the description box below to make it easy for you guys to find the sections that you're interested in. Let's go. So today's video is actually going to be all about arrays, and we're going to take two beginner level questions, which are going to be how to find a missing number in a range in an array. So what I mean by that is let's say you have a set of numbers between 1 and 10. There's going to be one missing number. Let's say 6. How can you find it? Our second question is to how to find duplicates within an array. So let's say you have the same set 1 through 10, but let's say there's a duplicate number in there. Let's say there's 2 3s instead of there actually being 1 through 10. How do you find the 2 3s? Those are the two questions that we're going to solve today in this video. So I have 4 solutions for you today. And so in order for you guys to understand these solutions, you're going to need to understand for loops, arrays, bitwise operations, and lists. Now, the last two are not strictly required because I wouldn't expect a beginner to know. I'm just going to be showing you some solutions that include them, and I'll explain them kind of briefly. I don't want to make this video too long. Instead, what I'm going to do is post some helpful links in the description box below of some articles and other videos that I think will definitely help you understand these two concepts. So let's get it. So let's talk about arrays. Arrays are a data structure available to you in Java. So arrays are fixed width containers of the same type. So they have a length of, let's say, 6, and they must be of all of the same type. So let's say you have strings. So in the side of this array, there's going to be 6 strings. So you can think of an analogy of a candy bar. A candy bar has a fixed width, and throughout the entire candy bar is nothing but chocolate and peanuts and things like that. You're not gonna find things like, I don't know, a banana or something like that. Array values can be accessed in 2 ways: the actual physical address in memory and an index. So we're not gonna be interested in the actual physical value in memory. You're actually gonna be interested in indexing. So let's create an array that has 3 names in it to make it simple for ourselves. Let's do Anna, Bailey, and Chad. So we want to access any of these names in here. We need to call the array as well as the position in the array that they're in. For example, to access Anna is going to be names 0. To access Bailey is going to be names 1. And to access Chaz is going to be names 2. So that's fairly simple and straightforward. In order to move through an array, we actually have to traverse the entire thing unless you know exactly what you're looking for. So for example, if you don't know where Chaz is, you'd have to loop through the entire array, which is pretty simple. You can do a for loop or a while loop, whatever is your preference, but you are going to need a loop in order to be able to access all of the values inside. So arrays are actually pretty great. They have a pretty quick access time and pretty decent traversal time. But because of this, a trade-off to this is that arrays are fixed width. So remember that candy bar example? So unless you want more width on your candy bar, you essentially have to go out and buy a new candy bar. You cannot create more length on the one that you currently have. Because of this trade-off, it's important to know when to use this array. So right now we're covering beginner problems. So I'm going to continue to tell you the appropriate methods to use in these solutions, but as we go forward, I encourage you to stop and try to solve the problems on your own and think about the different types of data structures or solutions that you would employ before skipping ahead and actually seeing what the answers are. But that's just a basic rundown of arrays. Like I said, if you need more information, I will post links in the description box below. As always, I will be creating a separate video explaining this topic a little bit later on. So on to the solutions. So the first problem is how to find a missing number in an array. So let's think about this for a minute. It's in a fixed width container, and we know the range. It's going to be 1 from whatever number is given to us. So if you think back to your math classes, there's actually a sum formula that you can use to find the sum of any range of numbers. And that's what we're actually going to do. We're going to find the expected sum. And once we find that, we're actually going to create a for loop and find the actual sum, so the sum of the entire array. And then what we're going to do is subtract the expected sum from the actual sum. The result is actually going to be your missing number. We're going to create an integer to hold our result, an integer to hold our expected sum, and an integer to hold our actual sum. So here I'm using a for each loop. This for each loop is very similar to your traditional for loop. I just chose to use one here out of, stylistic reasons. And you'll notice throughout this video that I do change from different styles back and forth. That's just how I prefer to program. I just don't like to forget things. And you'll see that in the body of our for loop, we're essentially just adding each index to the actual sum. That way, once we're done traversing the entire array, that we actually have the entire sum of the array. So now all that's left is to return the result of the expected sum versus the actual sum. And like I said before, the result is your missing number. Let's go ahead and test this to see if this is true. I'm going to create an array with the numbers 1, 2, and 4. The missing number is 3. Let's test our code. Indeed, 3 was the result. So this method isn't too bad. The runtime of this method is going to be O of n, and the memory usage for this method is marginal. This is a good solution, but it's not a robust solution. So what I mean by that is this solution works as long as you only have one missing number. The next solution that we're going to talk about is going to utilize the exclusively OR operation, better known as XOR. So this is what I was talking about earlier in the video about bitwise operations. So this solution utilizes binary addition. If you're not familiar with binary addition and how to add and subtract numbers with that, I definitely would suggest that you go watch a video on that, because the solution will not make too much sense to you. What I can tell you is that this solution essentially relies on the same principle. You're going to go through and get the binary addition of all of the expected numbers and get the sum of that. And you're going to do the same thing and get the binary addition of all of the actual numbers. And then instead of subtracting them, you're actually going to perform XOR on the expected versus the actual, and you'll receive the same result. If we look at the code for this one, it's actually pretty similar. We're going to write our boilerplate code. We're going to create an integer to hold the actual XOR of the range, and we're going to create an integer to hold the expected XOR of the range. And we're going to do the same thing. We're going to create that for loop, loop through the entire array, and then create another for loop and loop through what we expect. And like I said before, we're just going to XOR the result, and we should get the same thing. So, as usual, let's go ahead and test our code. this solution, in my opinion, is on the same level as the previous solution. It has the same runtime and the same memory usage. However, I would say that this solution might be a little bit worse just because of the fact that it can be a little bit difficult to grasp what's happening at first glance. Ideally, we want to write code that's very simple and easy to understand. This solution may not be understood immediately at first glance. However, this solution does prevent integer overflow. Now, if you don't know what integer overflow is, that's totally okay. It's just something to note about the solution. So something to keep in mind is that both of these solutions work regardless of if the array is sorted or not. Sometimes your interviewer will give you special characteristics such as the array being sorted or not sorted. And in a lot of cases, that can actually impact the solutions that you can use. These two solutions are going to work regardless of if they're sorted or not. So just some food for thought. Two solutions as to how to find a single missing number in an array. Let's talk about how to find a single duplicate number in an array. So perhaps your first thought is a brute force method in which you create two nested for loops in which you have the outer for loop keeping track of the placement in the original array and your inner for loop comparing each of those numbers to the outer for loop number. And that's not a bad solution. However, the runtime of that is O of n squared. And ideally, we'd like to get better runtimes of O of n squared. So a simple way to actually improve this solution would actually be to use the dot sort method that's available to us through the arrays class. So if we sort our method before we do our comparison, if we can compare a number to the number before it, then theoretically, if they're the same, there's a duplicate. Pretty simple. So as usual, we're going to write some boilerplate code. And then now we're going to use the dot sort method. So arrays dot sort is a very simple method. It just requires an array to be input as a parameter. This for loop is relatively simple, but something to keep in mind is that we actually don't want to start at the 0th position. We want to start at the first position. And the reason that we want to do this is because we want to prevent an integer out of bounds. When we get to the very last index of our array and we want to compare that, it would compare to the last index plus another index which doesn't exist. We can prevent this exception by comparing backwards, therefore we must start at 1. And so now we have a very simple if statement. If the index that you are currently on is the same as the index as the one before it, that means you have a duplicate and thus return that duplicate. I decided to return -999 to indicate that there was not a duplicate in the given array. And as always, we must test our code. So in this section, we have a 1, a 1, and a 3. So therefore, our duplicate is 1. And you'll see that's the correct output on the screen. So I mentioned to you before, what happens if you have more than one missing number or you have more than one duplicate number? And I kind of alluded to the fact that this would be a much more difficult problem to solve. And it actually is. And the reason I say this is because the first issue that you're gonna run into, that you see me creating here on the screen, is that you need to be able to return more than one thing. You must return the missing numbers and you must return the duplicates. How I decided to do this was to create a pair class. And a pair class is essentially a tuple. And a tuple is a key value pair. For those of you guys who are familiar, a tuple, you can consider a map of tuple, if you will. So essentially, I wanted one of the values to be missing values and one of the values to be duplicates. In order to do this, I had to create a custom class. And inside that custom class, I need to create a constructor to create an object of this custom class. And I had to override the toString method provided to all objects in Java and create my own custom one. Else, whenever you try to print out the results of this pair, it would not actually print out the actual values. Instead, it would actually print out their location in memory. once I finished creating this specialty class, I actually ended up creating 3 lists. Now, this is excessive. It's just what I came up with at the time. Essentially, what you're going to do is to create a list to be a copy of the array. You're going to create a list to hold your duplicates, and you're going to create a list to hold your missing numbers. So then we're going to create a for loop that's going to iterate over the array. And so what we're going to do in the body of this for loop is if the copy of the array contains this value already, this value is a duplicate. Therefore, you need to add it to the duplicate. But before you add it to a duplicate, you need to double check to make sure it's not already in the duplicate. So for example, if you had 3 times, we don't want to have 3, 3, 3. We only want to have 1, 3. So there's a nested if statement in here. And so then we come down to the final else statement, which is if the number is not already in the copy of our list, put it in the copy of our list. Now you can definitely write this portion in a different way. This is just the logic that I came up with when I was bored. So that handles the first part of the problem, which is how to find the duplicates. But there's still a second part of the problem, which is how to find the missing numbers. So what you do here is that you iterate over the copy of the array, and you use the same .contains method to ask it, hey, do you have the whatever value of I is? And you're going to iterate over the range which was given. The logic behind this if statement is really simple. If the copy of the array does not contain the number that we are currently on in the for loop, that number is missing, and therefore add it to the missing numbers list. Once we reach this step, we now have an entire list of duplicates and we have an entire list of missing numbers. All we need to do now is to create a new object of that custom class pair that we created and return that. And now you'll see why I created a special toString method. We're going to go and test this solution to see if it will actually print out the correct values. So let's create an array with 2 duplicates, 1 and 1 and 3 and 3. So this satisfies both. There's 2 duplicates and there's 2 missing numbers. 2 and 4 are missing and 1 and 3 are duplicated. So let's see if we get the results that we anticipated. Awesome, we did. So something to keep in mind is that this is a very over-engineered complex solution, and that your first solution that you come up with might not always be the best solution. So the runtime on this solution is actually not bad. It's actually just O of N, but the memory usage on this is terrible. Now you might be thinking, oh, you only created a list and one of the lists was a copy of the list. You need to think about it on a larger scale, because a lot of times what you might be working on in the future is data at scale. Let me give you an example. Let's say you were coding something for a social network, let's say Facebook, right? And let's say Facebook magically managed to get every single person in the United States on Facebook. Every single person has a Facebook. And you asked Facebook the question in the search bar, please tell me all of the people who are missing from my friends list that live in the United States. So using this method, it's going to create a copy of all of the people in Facebook just to compare it against your friends list to see if they're equal. That's a tremendous memory usage. And that's why the solution isn't the best. And just like that, we solved 2 different problems, and we actually solved a bonus problem that was based on the other problem. So I know that the last section might have been a little bit difficult, but I wanted to show you guys how adding one more condition to a problem can make the problem so much more complex and difficult to solve. So leave a comment down below which of these was your favorite solution. And as always, feel free to post your own solutions so we can talk about them. Maybe you came up with one I didn't even think of. So you made it to the end of the video, so I guess you must really kind of, like this sort of content. Well, you're in luck, because this is a series, so I definitely have other videos talking about other whiteboarding topics, so you can just, I don't know, go and watch some of them, see what you like. You might learn something. No pressure. I won't judge you if you decide to go and watch them.